Let's talk about that good old cancer-causing benzene. Okay, so when we start to look at a lot of our stinky stuff in nature, we start to call them our aromatic structures. The one thing that most all of them have in common is the fact that they've got this benzene group attached. Now, benzene is just a six-carbon ring. In this form, this would just be cyclohexane, but benzene specifically has three double bonds in it. Now, if you think back to you think back to our hybridization unit last year, we know that we could actually rewrite this with our Lewis structures to draw it another way. If we kept the carbons in all the same spot, we could technically shift all of those double bonds around. As a result, we sometimes say that these kind of pi electrons, the double bonds in here, are said to be delocalized. They're actually kind of moving free within, and so the bond order would be 1.5 on these as we were looking. That's why sometimes we see the superstructure for benzene, which is kind of our hexagon with the circle, showing that we've got kind of this kind of rotation of electrons throughout. And so this benzene ring, super important biologically when we start to look at how it starts to interact, because of these delocalized electrons are actually much more stable. That's why we see so many of them in nature and naturally occurring. So now if we start to think about how we go about naming something like this, we would actually, there's a couple different ways you can do it. There are kind of three classes of kind of naturally occurring. So you could have a benzene ring with a methyl group coming off of it. That's called toluene in the old language, back before we had our IUPAC system kind of hammered out. But if you were to give it kind of an IUPAC name, coming off here would be one carbon with three hydrogens. So this would be methyl benzene. Methylbenzene would be the kind of IUPAC name. Sorry, there's a terrible glare right there. Let me whoop. We are methylbenzene on our toluene here. Cool. We can also have, in terms of our benzene groups, we can start to look at our other structures for this. We also have our benzene group with an NH2 coming off the top. The old version for this was aniline, or if you remember your functional groups, this would be an amino, aniline, sorry. So this would be aminobenzene. The other one you can have coming off, that's kind of our third class, be an OH group, which you recognize as an alcohol group. So we could call this kind of toluene nope, got that backwards. Sorry, this would be phenol. Sorry. This is our phenol. Our phenol group, you could also argue that this is a benzenol or a hydroxyl benzene. Most likely you're going to see it as phenol in most all of your textbooks and or organic examples. Cool, yeah, and so as we start, you might start to see some of these names. So toluene, aniline, or phenol are worth noting, kind of these special cases. But oftentimes when we get that benzene ring, we just kind of start plopping functional groups on there. And so say you had something like this, you could go about naming this in one of two ways. You could say that this is 2-methyl, because if we're going to call this kind of our base structure, if you were going to call this our toluene, this would be the two locations. This would be 2-methyl toluene. 2-methyl toluene. That's how you would start to write that. You could also have it on kind of the third position. That'd be 3-methyl toluene. You could have it on then the fourth position, and it would be 4-methyl toluene. And so just depending on where that extra functional group is, you just adjust that methyl value appropriately. Cool, another example here. I should have kept my base structure, sorry. Let's have our OH coming off here, and let's do a chlorine and a fluorine. Sure, why not? So here is our our phenol. Keep goofing those up in my head today for some reason. There's our phenol group, our phenol. So we're going to give that priority because it's going to be kind of our base name. We've got then 2 and then 3 is going around to our functional groups. We could go the other way, but this gives us lower numbers. Alphabetically speaking, the chlorine's going to come first. We've got 2 chloro, 3 fluoro, and then phenol. All right, don't need that. So 2-chloro-3-fluorophenol would be the naming for this one here. There's an older version for doing this, or kind of common way of doing this. Ortho, meta, and para. I think for sake of time and ease, we're going to kind of leave that. If you are so inclined, the information for that is on our kind of, well, no, we should talk about it. Sorry. We got to do it. You're going to see it, and it's going to be worth being familiar with it. So OMP, aka OMG. OMP, OMG. So O for ortho, M for meta, P for para. Ortho, meta, para. So this is going back to kind of the common way in which we start to kind of identify where those different functional groups are. And so the ortho, meta, para tells us in relative location to one another. So if, for example, we had, I don't know, a chlorine and a chlorine, so you had two chlorines on there, we'd start by numbering one of them, number around to the other. You could say that this is 1,4-dichlorobenzene. 1,4-dichlorobenzene would be the official IUPAC version for naming this. You could also use kind of the common nomenclature. The furthest location away is our para location, or you might think, oh, they're parallel of one another. And so instead of doing the numbers here, you will sometimes see on bottles, and we actually have a bottle that says this, para-dichlorobenzene, as kind of the common naming for this. And so if we're thinking about our locations here, if it's 1,4, 1,4 is para. Orthodontist, get in your mouth, they're real close. Ortho is the 1-2 location, so if this was coming 1 and 2, this would be ortho. If it's locations 1 and 3, it is meta. And so kind of if we were to abbreviate as an O, an M, and a P, if our functional or our priority group is here at 1, our ortho would be here, our meta is here, and our para is here. Another example of that, because I think it can be kind of hard to see this sometimes. So let's say we had, let's do our benzene ring coming around. That's right in that glare for you guys, isn't it? Let's do a methyl group and a methyl group. So this is dimethyl. This is dimethyl. I'm just going to start by number one of them. We've got 1, 2, 3 going around. All right. So we could, if you want to use IUPAC, this would be 1,3-dimethylbenzene. I would totally accept that because from that numbering system, there's only one molecule that could be. Or you might say, oh, but wait. A methyl here is with a benzene ring. We call that a toluene. And so we could also say this is 3-methyl toluene. Sorry. 3-methyltoluene. Okay. Or if you wanted to, 1, 2, 3. The 1, 3 position is meta. This could also be meta 1, 3. Oh, sorry. Excuse me. You wouldn't need the 1, 3. Meta dimethyl benzene. All three of these names are technically correct. Yay, having multiple systems to name the same molecule. But all of these would give us one structure. It would give us the same structure in terms of our organic aromatic structures. Now, we're kind of looking at examples where they're the same. Good news, if you swap out one of those functional groups for something different, you just list them both, right? So let's do boop, boop. Let's make this a chlorine. Let's make this a fluorine. Sure, why not? Cool. I'm actually going to give priority to the fluorine. 1, 2 as we're going across. You could arguably give either priority here. There is technically a list of priorities, but we're not going to worry about that until you get into organic chemistry and your post-secondary. And so I'm going to go ahead and give priority here. Sure. So we could do this one of two ways. We could say this is 2-chloro, 1-fluorobenzene. Or we could say that this is, we got a 1, 2 position. This would be ortho, chloro, fluoro, benzene, yeah, got it. Both of these would be completely acceptable in terms of our nomenclature systems. Worth noting kind of the ortho, meta, and para relationship to one another. And I remember the order OMG, OMP, ortho closest, then meta, para is opposite each other. Now, this does only work on the benzenes. You can't use the ortho, meta, para on just, for example, cyclohexane or cyclopentane. We don't use them there at all. We would still do if it was just a cyclohexane. So say it was just cyclohexane and you had a methyl and a methyl, you would still say this is 1,2-dimethyl cyclohexane. You cannot use the ortho arrangement on this. It's just for those aromatic structures where we use kind of that secondary nomenclature system. Cool. Good to have some practice looking at kind of our aromatic problems, but hopefully it gives you a good kind of jump on how we start to write and name those organic molecules.